Hi, welcome back to Math 112. Today, we're going to talk about section 6.4, which is solving trigonometric functions. Now, we've kind of been doing this. If you remember a little bit ago, we answered the question, how long, how many minutes, would a rider on the London Eye be above 100 meters? But we didn't actually solve the trigonometric function, did we? So if we think about how that function looks, well, that's okay. So I kind of just did that through problem solving, right? In this section, we're going to learn how to actually solve the trigonometric function. And we'll do an example. Probably, yeah. So let's remind ourselves, remember the unit circle is really important. And speaking of the unit circle, I made a change to the Canvas course. Not really a change, I just changed the home page a little bit, which you probably already found, actually. So this is our Canvas course. And you'll notice I took some words off because we're far enough into the term now that the welcome words didn't make much sense. But I wanted to show you that I had put this flashcard utility on the course homepage. These are the, sorry, that audio is confusing, is distracting me, I'm turned off. These are the values, the cosine and sine of the values that I want you to know from the unit circle. Remember I gave you, I hope you found it, there's a unit circle, blank unit circle that I want you to be able to fill out. But if nothing else, what I want you to be able to know is, what is the cosine of 0? Yes, it is 1. Tangent of 0 is 0. So these flashcards, I'm commending them to you for your use. There's a lot of different functionality in this little Geezy Whopper. You can choose how you would like to study them. This is actually from Quizlet. There is an app if any of you would like me to set up a classroom so you can download the Quizlet app and have these on your phone or some way that is not your computer. Just let me know and I will do that right now. I don't have it set up. But what is the sine of pi over 6? Yes, it is 1/2. All right, so you get the idea. You can, I just use these as flashcards. If you want something a little more interesting, you can do scatter. Which, so the way you do scatter is, all right, cosine of 0, you know that's 1. So you find the 1, you drop it onto cosine of 0, and those disappear. You get the idea, right? The tangent of 5 pi over 3 is going to be negative root 3 over, no, negative root 3. All right, and you can drag them apart so they're not. And when you get all done, it will give you your time. And you can compare yourself to other people who have taken the same, done the same activity. This is a really good way to learn these. I want you to do these without having your unit circle open, because that will kind of defeat the purpose. So I hope you use these to remember, memorize these basic facts about trigonometry. And I will leave it to you. I will find one for some other things maybe and post it also on the home page. This is a great way to memorize what you need to memorize for this class. All right, let's go back to our presentation. And let's just jump right in. So I want to solve sine of theta equals 1/2 for all solutions. Now we can look at our unit circle and find the angles for which sine is 1/2. But that's only going to give me, sine, remember, is related to which? Yes, the y coordinate. So the angles that have a sine of 1/2, pi over 6 and 5 pi over 6. But remember, if we go around again, we will get to 7 pi over 6 and, no, sorry, 2 pi, 13 pi over 6. And so we add 2 pi to these every time we go around. The other way we can look at this. So we know that there are two angles that have this, for whom sine is 1/2. They are pi over 6 and 5 pi over 6. We know this from the unit circle. But if we go around again, we know we're going to get back to the same, whoops, not 2K. Well, yes, 2K, but so if we go around again, we know we're going to get back to that same angle. Plus what? Plus 2 pi. And then we can do that k times. Same thing here. 5 pi over 6 comes from the unit circle, but we know that every time we go around the unit circle, we get back to the same thing. We can also look at this in Desmos. That's what I've got set up here. I've just got sine of x, sine function, and a green line at y equals 1/2. This in projector mode so it's easier to see. And so right here we've got 5 pi over 6, 5 pi over 6, 13 pi over 6, 17 pi over 6. Now, we have talked about the inverse functions, so you may have been thinking to yourself, well, now, wait a minute. You just taught me about inverse functions, so if I want to know the angle whose sine is equal to 1/2, doesn't that mean that theta is actually equal to the inverse sine of 1/2? And the answer is yes, it does. And you may be tempted to say, well, my calculator can do that. And yes, your calculator can. And your calculator can even give you answers in radians. If you change your mode from degrees to radians. And let's see what happens if we put in the inverse sine of 1/2. I get 0.5235. Well, that's not helpful. Now is it? This is the difference between calculator answers and knowledge-based answers. So what I'm going to probably want most of the time, well, what I'm definitely going to want, if I say give me an exact answer, I'm going to want the pi over 6 and 5 pi over 6 answer. I'm not going to accept the calculator answer. Anytime that you can get an exact answer from your knowledge of the unit circle, that's what I'm going to want. So this is why you need to memorize that unit circle, because you need to be able to recognize when you've got something looking at you that you should know from the unit circle. Let's take a look at another example. Let's think about a circle. Yeah, let's do this one instead. I like this example better. We'll go ahead and use this slide, but we're not going to do this. You know how to do this. You would just graph tangent. Well, we can do it real quick. Let me get rid of all my eraser here. Erase this. So the quickest and easiest way to do this is to go to Desmos, graph tangent of x. So we're trying to find, what are we trying to find? We're trying to find all angles for which tangent is equal to 1. So let's just put a horizontal line on at y equals 1. And you should know this one. Tangent is equal to 1 at pi over 4, 5 pi over 4, 9 pi over 4. In other words, it's pi over 4 plus k pi. So this is theta equals every pi over 4 tangent is 1. Okay. Let's do another example, and I don't have this on a slide, so we're just going to write it out. We've got a circle with radius equal to 5 times the square root of 2, intersects the line x equals -5 at 2 points. We want to find the angles that associated with those 2 points on the interval 0 to 2 pi. Now our circle is going to be centered at the origin, so we need to remember what that means. So we can write the equation of the circle, and that is x squared plus y squared equals r squared, so that's going to be 5 square root 2 squared. So x squared plus y squared is equal to 50. We know the x's are -5, so we're going to plug in -5. So 25 plus y squared equals 50, and y squared is going to equal 25. So y is positive and -5. Well, okay. What you may be thinking is, well, wait a minute, y and x are equal, almost equals sine and cosine, or almost equals, that's got to be some 45-degree thing. And you're going to be right. Let's, though, just take a quick look at this on Desmos. A graph almost always helps. Let's put our circle on. My circle is x squared plus y squared equals, we said 50, but if you want to check yourself, you can put in 5 times the square root of 2, close your parentheses and square that. Okay, so there's my circle. Let's put on a horizontal line at x equals -5. And now, there we are, -5, 5, and 5, -5. Now, how do I know that this is going to be a 45-degree angle of some sort? Well, remember that my x and y coordinates give me the sine and cosine. So what I know is that the tangent of this angle, of the angle formed with the x, so the tangent of the internal angle is going to be -1. Actually, the tangent of the angle is going to be -1. But, so we know it's one of our special lines, right? It's one of our special points. We know that our tangent is -1. The other way we can do this is we know that, so we found the coordinates of the point, and we know that, okay, hold on, I gotta get back to my, there we go. So we know that y equals, there's a couple different ways to do this. We also know that y is equal to the sine of my angle. And we also know that x is equal to, well, r, not, so that's this times r. We also know that x is equal to r times cosine theta. So the quick way to do this is say, well, you gave me the x coordinates, so that means that -5 equals, and you gave me my radius, so that would be 5 times the square root of 2 times the cosine of theta. Well, divide both sides by 5 square root 2. So what I'm doing is I'm isolating my trigonometric function, and I get -1 over the square root of 2 equals cosine theta. And you're going to think to yourself, well, but I haven't memorized anything that has got a cosine of -1 over square root 2. You're right. But you've memorized something that's got negative square root 2 over 2 times the cosine of theta. And if we look at our unit circle, you'll see that, oh, this unit circle doesn't have 45 degrees on it. It's going to be, there is an angle right here that you should know. Pi over 4, 2 pi over 4. This is 3 pi over 4. And it's -1, 1. So cosine, actually it's not, it's negative root 2 over 2 and positive root 2 over 2. And then the other place where this is going to be is clear down here at 7 pi over 4. And this time my coordinates are root 2 over 2 and negative root 2 over 2. So add this to your unit circle knowledge. And what we know is my angles are 3 pi over 4 and 5 pi over 4. Right? Okay, so the unit circle is your friend. It pays to understand it. Will simplify your life. I'm going to leave, so this one I'll do with you. It's pretty much the same thing. First thing we do is we isolate the radical, or the trigonometric function. So we're going to subtract 3 square root 3 from both sides of this equation. 4 cosine theta is equal to -2 square root 3. Now divide through by 4. And cosine theta is equal to negative root 3 over 2. You are looking at the angles for which will have a cosine of negative root 2 over 2. Go to your periodic or your unit circle and pick up those angles. And they are 5 pi over 3, and 4 pi over 3. Whoops, nope, I'm looking at cosine. So 11 pi over 6 and 7 pi over 6. Memorize that unit circle. I'm actually not kidding. You need to know that unit circle. It's absolutely critical that you know the values that I have asked you to know from that graphic. Okay, let's do a couple of calculator problems. Sometimes it is acceptable to use your calculator, particularly when you're given problems like this. Sine of t equals negative 0.4. 0.4 is not a known unit circle value. So what we're going to do is we're going to use our calculator. We're going to put our mode in radians. So make sure your calculator is in radians. And what we're going to do is we're looking for the angle whose sine is negative 0.4. So that means t is going to equal the inverse sine of negative 0.4. Now we know that y is equal, or sine is associated with the y coordinate. So we're going to expect an angle in the fourth quadrant. So let's see what happens when I just plug in the sine of negative 0.4. I got an angle of negative 0.4115 radians. We'll have my problem says to solve this between 0 and 2 pi. This isn't between 0 and 2 pi. What's going on? Well, if we think about our circle, what we're looking at is something that is down here, right? How can I get to, and we know that we've got another one over here, right? So if this is negative 0.4115, and it is, because remember our range, what's our range on our inverse sine? It goes from negative pi to pi. What do I do? Well, to get to this one, I can add, what can I add? Add 2 pi. So take my negative 0.4115 and say, all right, I need to go the other way. So I'm going to add to that 2 pi. And I get 5.8717. Okay. You'll know the measures in radians are smaller. That's because 2 pi is only about 6.8. So instead of going on a scale from 0 to 360 like we do in circles, we're going on a scale from 0 to 6.83 and change. How do I get to my other angle? Well, let's think about this. So I got this one. This guy is also 5.8717 radians. How do I get to this guy? What's the difference? The easiest thing to do is think about it this way. This angle is equal to this angle. So that means this is also 0.4115. And this larger angle is going to be pi plus that. So what I do is I will take my pi and add to it 4.4115. 0.115. And I get 7.25. What did I do wrong? I added 4 point, not 0.4115. There we go. 3.553. Okay. I'm going to leave the rest of these for your consideration. There are examples just like this in your textbook. So open up your text and take a look at these. And let's work an example. The London Eye problem that I started this discussion with is actually solved on page 394 of your text. I want to look at a slightly different example, and it isn't this one. I want to do a real world example. So I am going to, we're going to use this slide. We're just going to ignore this stuff. Okay, so this is not what we are doing. I want to talk about, so the depth of water at a dock rises and falls, so depth of water. Is given by the formula f of t equals 4 sine pi over 12t plus 7. And t is the hours after midnight. If a boat needs 9 feet, I want to know at what times, between what times, will the depth be at least 9 feet. So when can the captain come dock his boat if he needs 9 feet of depth? What we're saying is f, we're trying to find the times for which f of t equals 9. So 9 is going to equal 4 times the sine of pi over 12t plus 7. Isolate our trigonometric function by subtracting 7 from both sides, and we get 2 equals, 4 times the sine pi over 12 times t. Divide through by 4, you get 1/2 equals the sine of pi over 12 times t. Okay, now 1/2 is a known unit circle value. We can find the angles for which sine is 1/2. If we look at our unit circle, we can see that the sine is 1/2 at pi over 6 and 5 pi over 6. But let's look at what's inside my trigonometric function. Is that theta? No. So what that means is that whatever is inside my function, in this case, pi over 12t, is going to equal pi over 6 or 5 pi over 6. So that means t equals 2 or t equals 10. So that means 2 hours after midnight and 10 hours after midnight, or 0200 or 2 a.m. or 1000 or 10 a.m. Between those hours, the dock, the water will be at least 9 feet deep. And notice that this cycle is going to repeat on a periodic basis. You can take a look at this in Desmos if you want to, but this is how we use trigonometric functions to solve real-world problems. And everybody have fun doing their trigonometry, and I will talk to you all again soon.